That's the spirit. Thank you for the ovation, for nothing, hopefully for something. My name is Wojtek. Here's the Slido page with the conference ID. So you can actually put the Q&A there. We don't have to then go with the mics. That was the information I got from the organizers. And the second organization announcement is that Philip told about the one of the workshops that could have a second date on Sunday. So from 10 to 12, there will be another slot for workshops that is about cloud data analytics, the serverless cloud data analytics. So everybody that are on the wait list, in a moment there should be another event in the registration system that you will be able to sign up, and then on Sunday there will be a workshop available for you. So hopefully this will help with the demand for that particular workshop that I'm also co-owning. And without any further ado, make it right from the start. This is a little bit interesting topic to talk about, especially after one single blog post that I will show you in a moment. Because when you work at AWS or Amazon, everybody are asking you about, are you ditching microservices? Are you planning to ditch the serverless? Are you moving out from the cloud? Obviously not, but this is a little bit of the talk was actually created before that blog post, but then I thought this is actually a nice showcase how you can actually design an evolutionary architecture and think about the evolutionary architecture from this point of non-functional requirements, the role of the architect, and actually designing it from the in the right way from the start. And the right way, it's contextual, and we will talk about it. So let's turn the tables because I talked already. How many of you are using cloud computing at the moment? Any cloud provider? Raise your hand, please. Almost all people in the room. Great. How many of you are using AWS? Oh, not so. No, okay. I am actually glad about that. That's good to hear. As I told you, I work for AWS, and all the examples that I will show you will be about AWS, but the talk is cloud agnostic. I will talk about evolutionary architecture, enterprise integration patterns. There will be a lot about the role of the architect. So there is not so much cloud-related stuff, but examples needs to be solid, and that hence they will be in AWS because I know it the best. One additional thing, if you are AWS customer, community member, feel free to reach me out after the talk, during the workshops or before the workshops, after workshops. I will be more than happy to chat with you. That's actually the role of developer advocate. If you think this is a made-up role, no, it's not. This is essentially a person that it's your voice inside company and someone who is actually listening to the feedback from the community. So I'll be more than happy to talk with you. But before I was developer advocate, I started as a developer advocate. I was also a software engineer, cloud architect, operations engineer. So I know my bits since like 2012. And this is actually my alma mater, so this is another nice thing to speak here. Without further ado, again, this blog post. How many of you seen this blog post in the social media? Raise your hand, please. I'm actually surprised that not so many of you. Okay. For those of you who haven't heard about it, this is essentially a blog post from Amazon Prime Video team that they moved to monolithic architecture from microservices to save up costs. And this went huge over the internet. Many people actually caught on the train, drank the Kool-Aid, never read the article, and actually made a lot of sensationalism around this about who is doing what and who is ditching what. If you will read this article, but this will be actually a good question. How many of you read this article? Okay, even less hands. That's not surprising because that's a lengthy one. And also, the most important caveat from this article is that this is one of the things that this team actually made to justify their evolutionary path. So they started with microservices, but they started with serverless architecture, but essentially they identified that this kind of workload is not suitable for that part of the architecture, and then they re-architect. They went to something that is sometimes called a minimum viable architecture. There's a great talk about this. If you type it into YouTube, you will find amazing talk about minimum viable architecture. And I really like this term because this is essentially explaining what this team actually done in the first place and why they took the evolutionary steps to move to monolith for their workload. This is also well described in the article, that they identified that the workload is actually stateful, not stateless, which is not a good choice for a serverless approach. Then they identified that they can save cost if they will move from a microservice, very distributed architecture to something that will be more monolithic for that stateful workload. So essentially, they identified across their path when they refined the workload, knew a little bit more about the business and the domain, that they need to evolve. But as I said, many people actually jump on the train, try to make some made up or plain wrong conclusions. And this is well summed by a distinguished colleague of mine, Adrian Hornsby, about pitfalls of sensationalism and technology enthusiasm. And I strongly recommend you this blog post because this is actually a very well debunk how this team is working. And even if you read this article and you have the impression that Prime Video, Amazon Prime actually completely moved from microservices to monolith, that's not true. It's just one component, one team, one decision. It's not always a black or white choice. And this will be a recurring theme today. So let's talk about a startup, a fictional startup that has a very little knowledge about cloud computing, but they know everything about software development lifecycle. They are an experienced team. They know, for example, a lot about the Python, all the language ecosystem and everything around it. They want to build something revolutionary, and they start, obviously, with the product in mind. In this case, this will be a revolutionary idea for providing a stock exchange for fictionary assets, for example, NFTs or unicorns, whatever you would like to. They start with a simple idea in mind, very well-defined business value and unique value proposition for the market, and then they want to start as soon as possible to validate the idea. In order to do this, they need to move fast. So what they do, they use what they know. Essentially, they will use virtual machines, they will use very simple ways to connect it with the domain. Maybe they will use a particular NoSQL database because their CTO don't like SQL. This is opinionated choice, again, very contextual for them. But the most important part is about the starting point and time to market, because they want to minimize the time to market to actually validate the idea. Then there is a second phase. They are having, obviously, a huge success because that was a revolutionary idea. Market was very warm, very prepared for that. They want to use it. There were customers asking about new features, so they want to scale up. Another phase, when they need to refine, they need to back a little bit when it comes to the architecture choices. They need to decide whatever would like to do in the future to do it scalably. And they decided to actually move from virtual machines to something more scalable, to something more fully managed. They learned a little bit more about AWS features. They chose load balancers and also AWS Fargate as the containerization engine for their application side. They didn't change the DynamoDB because they think that it fits the purpose. It also scales well, so they decided to actually do those steps to scale. And then there is obviously a third phase. When the scale is actually increasing, there is also complexity increasing. And for many businesses, this is a place when they need to actually bridge the gap. They need to jump over a gap that they created. Maybe there's a lot of technical debt. Maybe they moved too fast at the beginning. They scaled up. Now it's time to actually refine, clean, and move more stable in a way that they will grow in more predictable way. This is again a phase when they will do a lot of re-architecture, a lot of iterations around their design, the evolution. And again, they will use different tools to do this, including some additional tools introduced to the stack to satisfy new requirements. Because obviously when you are growing and you are scaling, you are not just satisfying the existing needs and existing business requirements. You are actually doing a lot more because clients are asking about new features, so you need to actually develop new stuff. So they need to introduce new things in order to satisfy those business and sometimes non-functional requirements. They need to introduce new things to the picture, like here they introduced a batching system for third-party integrations via partner and marketplace that they want to build. They introduced SQS, but again, they decided that even if their API and batching system looks very similar, they should handle it in a very similar way on the application side. So that was a deliberate choice for them to not actually re-architect everything, but rather focus on the code patterns to preserve the way to scale and the simplicity of what they built. And obviously there is a fourth phase when they are actually optimizing, they are squeezing the margins, they are trying to get as much money as possible from the market, from their niche, from their features. And in order to do it, they need to be efficient, also on the infrastructure side. This is the whole thing called operations, business operations, technical operations, but they need to be involved in optimizing stuff as well. So they decided to actually switch some services to something more managed, that has a different pricing mechanism, more predictable for them, and they decided to actually do it in a way that they will reuse their code. So this is the fourth stage and the fourth phase of the evolution. Now is the question, what is the role of all the team members, including architects, in the whole journey? Because you may ask, this is very well explained on the slides. It's always beautiful when you are having nice animations, diagrams, and everything is moving from left and right. But how it looks in practice? In order to answer that question, we need to think, what is the job of the architect? Can you shout out to me, what is the job of architect in your opinion? Software architect. Very general way to say that, yeah, but to design a system. What do you mean by design? Good. What else? Make it cheap, yeah? What else? Good. You are actually explaining a lot, you are referring, both of you actually, to non-functional requirements at the moment, right? Maintainability, cost efficiency, what else? I think when I will ask all of you independently, what is the job of the architect, you will get totally different definitions, because for many organizations and for many viewpoints, this role is actually very non-unique in that sense. So we can actually have a common ground, and with the tongue in cheek, obviously, the job of the software architect is to architect the system, as you told, to make it work. But what does it mean to architect in this particular case? If we will refer to the most important books that are created for our industry, like this one that is about documenting software architectures, the software systems architecture is about relations between different components. So not only the boxes matters, but also lines between them, because those lines are actually carrying information about very important non-functional requirements. Also, the relations are defining the flow of the information in the system. They are defining how the information is actually moving from left to right, from start to end. This is also an important piece when it comes to those non-functional requirements, but also to those functional business requirements that we are implementing. My distinguished colleague told that how those systems interconnect is actually defining how systems will behave on the high level from the non-functional perspective. Because those connectivity patterns that they are using are actually defining the system's essential properties and traits. And he actually very well phrased that in the book called Enterprise Integration Patterns. How many of you heard about this book and read it? Not so many. At the end you will see the cover. I strongly recommend to grab either the physical or electronic version and read it, because this is something that it's not exactly enterprise oriented, even though the title suggests that it's just for the enterprises. That's not true. It's for the distributed systems, and we are building distributed systems nowadays in all companies. So when we will back up a little bit about what is the role of the architect, I think the goal of the architect is to see more dimensions and direct the discussions in the proper paths in order to provide multiple views, multiple opinions, and actually decide from those opinions which decision will be the best one. So as you can see, we have two people on the slide that are arguing if they are seeing rectangle or circle. I know this is a made-up example, but I think many of you can refer and see exact same discussions in your teams when you are choosing a particular language library, particular design choice, and you are actually arguing between each other about one or another. The role of the architect in that particular agreement is to see all the trade-offs, identify them, and then based on the argumented evaluation, provide all the possible options with the consequences. Speaking about consequences and those argumented options, modern architects should not see something as black or white. Not just microservices are best, not just monoliths are best. All of you know that everything has a trade-off, and this is one of the key things that it's most important in our roles, that we need to be able to identify all the trade-offs, all the shades of gray, and choose properly from those the best solutions. And with the shades of gray, there's obviously a part related to the trade-off. There is no free lunch, there is no silver bullet. Many other things actually argumented in many different essays in our industry. And we know this for a very long time, that those options aren't free. They require effort, they increase the complexity of the system, they cause underutilization in other aspects, because if you will invest time in one area, then you will definitely lack the time in others. So this will require actually careful evaluation of all the consequences for that particular trade-off. And modern architects zoom in and out. I know this is a very trippy example, but this is essentially a good approximation how we visualize in our heads mentally, at least majority of us, because not everybody are thinking the same. But majority is actually visualizing in a very similar way the architectures. We are zooming in, zooming out, like on the map. You are able to see the globe from a very high perspective, but if you will need to see a detail of a single city, you are able to zoom in, increase the scale, and then see more details on that particular city on the very low level. And we do this in order to actually help our cognitive abilities to solve all those potential issues, to identify drawbacks, to identify trade-offs, to see the consequences when we are designing the systems. So this is actually about observation and how to do it properly on very different scales. With this zooming ability, there is one additional thing that is, in my opinion, very important in the role of the architect. You can measure how much value and how much impact a given architect will have in the organization based on how many levels he can talk to or she can talk to. If you think about it, it means that that particular person needs to talk with the business executives at the very top of the building in the penthouse, and at the same time, that person will enter the elevator, go up to the bottom to the engine room, and will be able to talk with those people at the engine room about exactly the same problem, but on a very low level when it comes to details, experience, expertise. So in other words, great architects are actually spanning between all of those layers inside the organization, and they are able to communicate the needs, the trade-offs, the options on all available layers. And this is not my analogy. This is again analogy by Gregor Hochbe. He coined it and named it as software architect elevator and defined all those following steps that are visible on the slide. So as a modern architect, you should be able to connect business and IT strategy. You need to be able to drive change and to go through that change. And that requires a lot of soft skills or something that we are calling in engineering as soft skills. we need to identify, conquer, and manage, tame complexity. We need to think about how to explain, visualize, excite, inspire other people. But on the other end, we need to have hard skills as well. At least those we are naming as hard skills in engineering, like designing internet scale systems, knowing about nitty-gritty performance, knowing about nitty-gritty details about performance or particular engines. We need to remove friction. We need to know how apply particular best practices to remove the friction. And we need to be able to keep up with the change that is coming in our industry. In other ways, you can say that modern architects should connect the dots on multiple levels. So if someone is actually identifying that we as a business needs an ability to rapidly change, to rapidly deploy, we need to have velocity, we need to have observability in our systems. You need to know what kind of non-functional requirements are involved in this. You need to know all the techniques that are combining those two worlds, and then you need to apply them in a correct context. And you need to apply them in the correct context because there are multiple techniques and multiple patterns, best practices available to you. But in order to do it, you need to be certain that those particular set of trade-offs that you will have afterwards will be manageable later. And speaking about the trade-offs and how to break those constraints, usually when you are thinking about architects and how they are designing the systems, you can say that they are designing systems in a either or another way. Like you can either have standards or innovation. You can either have customization or low cost, either short-term gain or long-term gain. The truth is that some more experienced colleagues have those experiences, have those knowledge, how to apply certain tools and techniques that looks like magic because they are actually going and breaking those constraints and they are bridging those worlds. But that requires expertise, experience, learning on the mistakes yours or on other mistakes. And that will be also one of the job of the software architect, to be able to identify how those techniques that they applied in the past actually transfer into the new environment, the new context. So to sum up, what makes a modern software architect? What kind of traits are required? I think the major analogy we can have is to work like a chef in a great restaurant. It's not about selecting the ingredients. As a chef in a great restaurant, you won't be responsible personally for buying individual groceries, but you need to know how to combine them to achieve something great. You need to know how to put them together to achieve a synergy or something greater. Another thing is you need to focus on the impact, and you need to scale that impact on multiple levels in the organizations. Again, I'm a strong believer that you will be much more successful in a role if you will be able to talk with the business, and at the same time you will be able to talk and be kind of respected by engineering as well. Because otherwise, how you can talk with them from the position that you will be able to convince them about something. And on the other way, how you will be able perceived as business as a trustworthy person to investigate certain ideas or to actually do certain stuff. And third one, you need to be authentic and you need to sell options. And by selling, I mean present them in an honest way, very argumented, not giving them away for free. Those options are not free, there are no free lunches. I think we know all that. So you need to be honest about the research, you need to be very explicit about the benefits, but also about the drawbacks. And you need to know how to identify them, how to properly evaluate them in your context. If architects are expressing internet capabilities, they should think about patterns, they should think about high-level things, and not about the products. I think the architecture shouldn't be a software bill of materials. It should be something that you are actually combining on a higher level, but then with the knowledge that you have about particular offering, about particular tooling, technologies, frameworks, whatnot, then you will be able to actually apply them in a proper context. Again, you are the chef. You are not shopping for the groceries. You are actually identifying what will work together, and then implementation details. Even that you know a lot or a little bit about them sometimes, that should be something that you will delegate. So let's back to our tale that I have in the chapter number 1, that I show you all the 4 phases that are more or less compatible with the evolution for all kind of businesses and startups. So in the phase when we talk about validation, what was the most important thing? Shout out, please. EC2, we are talking about technology, but what was the most important thing about the business thing from the validation perspective? Come again? Yeah, exactly. It should work. It should be deployable as fast as possible. It should be verifiable as fast as possible, available for the business feedback. So again, they chose those technologies because they know how to run it. There's no fancy Kubernetes here. There's no serverless. There's no other fancy technologies available. They chose plain virtual machines because they know how to SSH there, how to operate, how to deploy. It's not the best practice, but that was right at that time. Being right about that time is about achieving the integration synergy, and there's no such thing that you will achieve integration synergy once and then you will sustain it for independent time throughout the project. You will actually, you will be able to do it if the conditions, initial conditions will not change. By conditions, I mean business requirements, environments, market, but those things are actually changing. So you need to adjust yourself and achieve the integration synergy later, depending on the changing variables. And speaking about synergy, again, this may look like a list of technologies from AWS, but what could be used in that particular example by them as they deployed on AWS? They could use Code Whisperer for quick development and prototyping. They obviously used Route 53 for managing domains. They used EC2 to manage virtual machines. They used DynamoDB for store the database details inside fully managed NoSQL database. Again, a set of technologies that they chose from the portfolio, pragmatically choose what they know, what they will be able to learn in the quickest way, and to satisfy their actual needs and in their actual context. So we have the phase 2. They achieved success. What is the most important thing in that phase? Shout out, please. Scale up. You need to scale up, you need to move faster, you need to expand in a much more predictable way, you need to be able to monitor, to observe, to actually move with your infrastructure much quicker than in the previous case. You validated the business idea in the previous phase. Now it's time to grow, but grow in as fast as possible, because you need to tame the market, you need to attract people, you need to convince that your business is actually worthwhile and have those customers on board. So they changed the architecture, and that was actually a very incremental change. That's not something drastic they did. From the level of proper code and architecture organization, going from phase 1 to phase 2 actually requires redeploying one thing and packaging your application as a container. That's it. Configuration around this is actually not so complicated, and incremental change is very easy to do. What they did in the first place when they invented the first, you may say, prototype as a scrappy thing, that was a thing that they decided to do deliberately, because they decided to build something that will be changing over the course of the years very frequently. They knew from the day one that they will not stay in that architecture because that will not satisfy their needs. So it's better to put something scrappy and then evaluate and move from that insights in one or another direction. So again, what could they use in that particular phase? I told you about the load balancing because that was the obvious thing. Obviously, they had to move the compute to AWS Fargate because they decided to scale it in a more rapid way. Why didn't they use auto-scaling groups? Because maybe they don't want to be bothered by the infrastructure management. They want to focus on the business side. So that's why they chose a fully managed system and service provided by the cloud vendor instead of actually focusing on designing and tweaking their custom auto-scaling rules. And they also identified that infrastructure shouldn't be managed as pets, but rather as a cattle. So they wanted to invest more into infrastructure as code approach, into having provisioning properly done in a programmatic way, and to stop actually clicking and treating the infrastructure as something they develop by hand. And again, with other available products and services, they identified that they would like to store the configuration details in external services to actually enable the scaling capabilities. So they identified that they can use Systems Manager to actually store those secrets and credentials that are available in the application. Again, their set of choices, but actually this is a very pragmatic set of choices again. Phase number 3, stable growth. What they changed now is they did a little bit step back. They thought about how to design the application properly to be prepared for growth, for adjustments, to actually adapt to the changing business requirements, because you can see on the slide that you are not having a single path going throughout the system, but another one that it's identified as the partner integration. And they identified that with that particular partner integration, they would like to use a queuing mechanism that is available in AWS called SQS. But that will actually send a very similar messages and events to their infrastructure as the regular API. So they decided, hey, why don't we abstract away certain things and then design our code layer in a proper way to actually embrace it. How they did that? They employed something called a hexagonal architecture, or something that is called ports and adapters. How many of you heard about it? Okay. For those of you who haven't heard, there are 3 important concepts here. One is this hexagonal or onion inside that is containing the domain logic. This should be a fully abstracted way of for your business logic, for your code, that does not have any third-party dependencies included. This is pure business logic. If you are seeing here references to domain-driven design, for example, this would be a very good analogy to have as well. This core domain logic is actually stored in a very pristine way, that it's not polluted by the third-party references. And then if you want to integrate with external world, you are actually defining an integration points called ports. Those ports are ways to interact with the external services, with other components in our infrastructure, with third-party elements available on the stack. And then those ports are defining an abstract ways and contracts to interact with the world. Now, having this, you need to implement something that will actually do the work with the external world. And here's the third component called adapter. This is actually implementation of that contract that interacts with the service. And if you are thinking that this is a lot of work, you are right. This is much more work required than just hack the prototype. But at the same time, it gives you a flexibility to actually interact with multiple different ways with your core domain logic. So again, if you are receiving API requests and batch requests from queue, you can actually handle it a little bit different, but with the same core business logic. So the handling differences will be stored inside adapters, not inside your core business logic. Another benefit is that you can actually switch the adapters to be testable locally. And that will actually increase the stability, because you will be able to write better code, write in an easier way tests, and create something that will be much more manageable from the code and architecture perspective. Again, you will be able to achieve this with much bigger work, but still, this is a code level pattern that has some kind of consequences on the architecture side and integration side with your services, because this will actually affect how you are deploying your software, how you configure your software, how much work will be when it comes to the having test or local environments. So again, a proper code architecture pattern applied in a proper context actually helps you with the later decisions that you need to make to grow, to optimize, and in later phases, hopefully. So again, what they used here in that particular phase. So they could use SQS, as we told, to handle the batching request. They could invest even more into the CI/CD stack from AWS. They don't have to, but they could. If they want to, for example, store artifacts, their reusable code, their business logic, their domain code, they can invest in something called code artifact to store the particular libraries in the inside the repositories that are reusable across the organization. If they want to build CI/CD system from the blueprints that integrates with the third-party sources or third-party providers like GitHub, like Terraform, they could use Code Catalyst for that. And again, they could use Code Whisperer to actually write those tests to speed up the whole refactoring part in order to support their move to the hexagonal architecture to ports and adapters. And there is a phase number 4, when you are focusing on optimization. Obviously, you are switching here, again, 2 different services. So the difference is that we are not having the load balancers and we are not having the Fargate. Instead, we are having Lambda, which is a serverless way, function as a service solution, and Amazon API, which is a REST API in a fully managed way. Why they switched that? Because in that phase, they identified they need to actually be very cost effective. So what they wanted to do and want to have is to have predictable pricing based on the usage. So they only pay only for the stuff that it's running and for the requests that they're receiving. Comparison with the previous point was they paid even if the architecture, even if the infrastructure was idle. Now they are having something that it's running only when it's needed. So this is a huge win from the optimization point. They used, in particular, Lambda, as I told you, to actually leverage the serverless pricing to have no cost when there is no traffic. The same goes with API Gateway, to have no cost when there is no traffic. If they wanted to implement some additional patterns when they integrate with the third-party systems, they can also use another services available in AWS to implement those patterns. For example, a circuit breaker pattern, which allows you to stop sending requests and overwhelm a third party when there is a failure on their end, and then recover properly if they will recover as well. You can actually implement this with the step functions. And actually, Anton will talk a little bit more about this in the next talk. And obviously, they stayed with DynamoDB because actually they gave them, from the beginning, with a very right choice for their context, they gave them the same traits as the ones that they have important and identified as important in this phase. Again, no cost when there's no traffic. What could be next? Because obviously this is not the final step for their evolution for the phases. Obviously they can identify the need for security. They need to invest more into the security of their infrastructure because they want to be either audited or they will go through some regulation requirements. So they need to invest in security. Obviously, they need to invest in governance when they will grow, especially if they want to have marketplace, multiple partners, multiple integrations. Again, there are some services available for them to support. Maybe they want to invest in monitoring and observability even more because they will need to do it to actually grow and scale properly. And last but not least, maybe they will need to have a predefined reporting regarding their cost savings and cost infrastructure. Everything depends on their business journey, but having those decisions on the way and choosing that properly with the proper architecture role actually enables them to do it in a much more reliable way. Another thing would be when they want to implement something on the code layer, for example, implement even higher dependency on domain-driven design or trying to be more aligned with those particular rules. Again, this will have consequences on the infrastructure side, but they already prepared for that because in the phase 3, they already did a lot of refactoring and the groundwork. And maybe they would like to introduce another stuff. Maybe they identify need to have the command query responsible segregation pattern. Again, they will start with the code, but when there will be a need to scale on the infrastructure level, the code pattern, because CQRS is a code pattern, not as some of my colleagues at AWS think and sell it as an infrastructure pattern. When there will be a need to identify this on the infrastructure level, then they can scale with something that is available on the platform. But at the beginning, they need to apply it properly in the code and then benefit from that later. So to sum up the whole journey of the startup and the whole role of the architect throughout that journey. Again, what makes the modern software architect a great persona? We should act like chefs, select ingredients, not select ingredients, but rather know how to combine them to achieve something greater. We need to be focusing on impact and talking with multiple stakeholders on multiple levels and actually focus on doing a lot for our organizations to understand and communicate between multiple layers. And we need to sell those options in a very honest way. We need to be authentic, we need to be honest, we need to be pragmatic and prepared. There is no free lunch. I know this particular quote may sound a little bit cheesy, but I think it is a very right approximation how you can perceive the role of the cloud in the whole thing. If we will try to build certain systems like 15, 20 years ago, we will actually invest much more money and much more work into having something than nowadays. And that's great. That's the benefit of progress. But at the same time, architecture and thinking about the role of the architect shouldn't be focused on the choosing just the products and combining them together and doing the mashup. Role of the architect is to actually design the path in a way that it should be scalable, maintainable, and satisfy other non-functional business requirements in as many changes and as iterative process and seamless process as possible. So again, you should express intent and behavior and not think about products, about particular elements that are available underneath. For those of you who want to learn more about evolutionary architectures, I can definitely recommend all of those 4 books. I already mentioned about 2 of them. Enterprise Integration Patterns is a classic, definitely recommend. Software Architect Elevator for those of you who want to learn more how to make an impact. Cloud Strategy if you are investing into convincing business that this particular move to cloud actually matters. And Building Evolutionary Architectures as a great book about how to do it in an iterative, very seamless way. If you are looking for best practices for checklists, I can definitely recommend the 12-factor app or 15-factor app, as it's called nowadays. But this is one of the things that are pretty well known in the industry, and I think I'm not rediscovering anything specific here. This is also a good checklist to actually identify, have I ever thought about this particular area, or did I also cover all of those areas in my application? But again, this is one of the things that we already know for a while. If you would like to learn more about the additional resources, I can definitely recommend a serverless land hub, which may point you by the name that this is all about serverless. The truth is that it is not only about serverless, it's more about distributed systems, how to design them properly, with an emphasis on event-driven architectures. And there are 3 talks from the past reInvent that are actually having a lot of the interesting points about how to design distributed application, how to connect between the multiple layers in the organization in the via architect elevator, and then how to build next-gen event-driven applications. My name is Wojtek. This is everything I prepared for today. Under this QR code, you will find a feedback survey, so I would be more than grateful if you can provide me the feedback about the talk. And hopefully we'll have a little bit more time for questions on the Slido. Thank you very much. I don't think so.
I was not so sure. Okay, yes. I have found the power button. Okay, so we have collected a few questions, and let's start with the ones with most likes. So why going distributed microservices first and then optimizing to monolith has become the default choice? Doing a monolith MVP and then scaling seems to be a better idea.
Okay, so this is actually a great question. I think the author of that question refers to the Prime Video example, right? Because I haven't advertised this as a default way in the talk, hopefully. So regarding their choice, they identified this as their starting point because they wanted to build something quickly. And they knew the serverless way, they have experience with serverless, so they designed everything in a serverless way, and because that was quicker for them. So that was actually the right choice that they made at the beginning because of their context and their pragmatic decision. But I wouldn't say that this is a default one. That's why this blog post is so interesting that it actually resonated with so many people in the either right or wrong way, because this is not a default way, and I'm actually asking why is not the default way for many organizations, or why it's not 50-50. I think that microservices gained a lot of traction, a lot of interest, and there was a point in the time that many organizations actually jumped without even checking if there is water in the pool, jumped head straight to those pools, investing into microservices without even thinking what there is a point of their business or what is the importance. So I would say that microservices actually have a very similar situation, maybe even now still have it, but nobody actually questioned that in the first place. So I wouldn't say that this is a default choice. And in case of Prime Video, that was a most pragmatic choice about what they know. So that's why they chose that.
Thank you very much. And the next question, do modern architects write code or just the design?
I do. I consider myself as an architect still, and I do, and I write code. But I wouldn't say that this is the best time spent in the project. You know, as you are reaching the seniority, or you are a staff engineer, the very popular one nowadays, you know that there is much better way to scale yourself in a project than just writing individual lines of code. You can actually be much more productive if you teach people how to do it better, if you scale up by sharing knowledge, if you will do mob programming, code reviews, etc. I would still value people that are writing code because they are keeping up, they are trying to be up to date, and I'm certainly do. But I wouldn't say that this is the best time spent. Especially that nowadays we have chat GPTs, copilots, whatnot, that are writing those code for us.
Okay, thank you very much. Next question, why use cloud native products when they might be switched off? A different provider might be chosen in the future. Why not use, for example, Kubernetes from the beginning?
Oh, that's my pet peeve. If you will get Kubernetes from the beginning, and convince me, because I'm also one of the people, I'm a person considered as not a hater, but rather someone who is very carefully considering using Kubernetes from the get-go. For me, it's like choosing microservices from the start. If you know Kubernetes, if you have operational knowledge about it, yeah, go for it. If you don't, I think you would jump on the hype train. And speaking about why to choose cloud native services, again, I would say pragmatic choice about what you know, what is your operational knowledge, and what are your priorities. If you want to write business code, validate business idea, you should rather focus on writing that business code and not to write the code that will scale up, maintain the infrastructure, prepare everything that it's underneath and whatnot, because that will be essentially a waste of time. So I would say that this is, again, a pragmatic choice if you want to focus on time to market, if you would like to focus on something you know, and if you are a Kubernetes expert, this will be your default way, yeah, go for it. There's nothing wrong with that. I'm just referring to the hype train that I mentioned at the beginning.
Okay, thank you. How many different cloud-related job positions would you point out? The common ones are DevOps, cloud architect. Usually companies use confusing naming.
Again, my pet peeve. DevOps is a culture, at least I believe that DevOps is a culture. Back in the days, we called those amazing people operations engineers. We still do in some companies. So I would say that in those particular things, if there is a company that has emphasizing on cloud architects, DevOps engineers, cloud data platform engineers, and whatnot, this is maybe a consequence of a hype train again, because maybe they wouldn't be able to find those roles because people will not be interested if there's no cloud in the title. And I don't know if that's only my perspective, but I think that in many cases, all of those roles which are having rockstar, cloud, they're essentially a similar thing, like selling a little bit better the position that we would like to achieve. So I wouldn't identify any roles specifically for cloud. I would treat cloud in this particular case as a capability, as a tool that you need to master in order to deliver something. I hope this makes sense.
Thank you. What is your experience with different infrastructure as code solutions like Terraform, Pulumi, or CDK?
Again, this is, I might be skewed, obviously. I'm using CDK because I know it the best, but I also use CDK for Terraform. I use Terraform. I use very little Pulumi. So comparing all of them, if we are referring to those, let's call them three, I would say that my preference is skewed towards CDK because it provides you the regular programming language. And the second choice would be then Pulumi because, again, a regular programming language. Outside of being operations engineer, I'm also a programmer. I still like to do it. I don't know if I'm a good one, but I like to do it. But at the same time, I feel that I can employ much better practices when it comes to modularity, having a regular programming language than essentially a DSL. And that's my private preference. Some people actually prefer to have DSL, to have constraints. I'm not a such person.
Okay. Is the mentioned code whisperer already competitive to GitHub Copilot? Some time ago it was not, unfortunately.
Yeah, so that's a good question. If you are comparing any tool on the market to Copilot, this will be a very harsh comparison. Copilot is the leader at the moment, is the most advanced one, and considered the best. I would say that nowadays Code Whisperer is still having some drawbacks, but it's much, much better than at the beginning. So I'm giving it a try. I'm experimenting with it, I'm providing feedback. You can also do that. But if you will compare feature-wise and ability-wise, Copilot is the leader at the moment, and that's a harsh fact.
Thank you. How to move smoothly from other cloud providers to AWS?
Again, this is a very complicated topic because it depends on the architecture. But one of the ways, and actually Gregor Hochpe has the great article on his blog about it, is to employ proper code and architecture patterns. And people are actually, so there are two things with the migration between cloud providers. Many people will actually try to sell the multi-cloud idea, and they will tell you that there are some tools helping with that. The truth is that everything depends on how the architecture looks like, how the code looks like. If you will have proper patterns employed, probably you will be able to benefit a lot from fast moves and fast migrations, especially for the workloads like containers, function as a service solutions, and so on, because those are not as hard to move. There are some things that are much more harder to move, like data, for example. And data gravity is an issue and as a thing. And many companies are actually focusing on moving between those clouds and providing services to move the data between. But this is actually one of the most expensive and most time-consuming processes in many organizations. So I would say that everything depends on your architecture, on your workload, but there are some ways to do it. Hexagonal architecture is one of the ways, because if you will properly identify the core business logic and identify ports and adapters, then you should be able to replace those adapters into something different, and with minimal effort, reintroduce it in with a different provider. The same goes with best practices around, for example, 12-factor app. If you will export the configuration, you will be able to do it a much easier move between the providers. And there are many, many other practices that are helping with that. And I would say that no tool, no service at the moment will save you from this, only patterns and good practices.
Thank you. What about the quality of ingredients? Architects should also choose the right ingredients, not only combine them.
Good. That's a good question and good call out. Yes, I said that you shouldn't be responsible for selecting the individual ones, but at the same time, you're very right about making sure that what's delivered is actually having a right quality. And this is the place when I'm actually referring to those trade-offs and those shades of gray. You should be able to evaluate all the things that we are using as the architect, and this will be your role to actually evaluate it in a way that this will be properly justified use, if that makes sense.
Thank you. And the last question. I read that WebAssembly is the next thing that will happen after VMs and containers. Any thoughts about WebAssembly and cloud?
Very good question. I'm not an expert on WebAssembly, but my origins are coming from the front-end side, and that was actually 2017, 18, when I first heard about that. That was called WASM at that time, or something similar. And yeah, this is like a year of mobile, year of Linux on the desktop. I'm not entirely sure that this will replace all the workloads, but at the same time, it's a very appealing thing to have a unified runtime that you will be able to compile to. I think this is a great idea. If there will be an initiative that will unify it between cloud providers and they will agree on this, this will even more enable us to move between them. But at the same time, I'm not an expert, but I don't think this will be a replacing thing for all kind of workloads. Because again, everything depends on the functional and non-functional requirements. In some cases, this will be justifiable. In some cases, maybe this will be too slow, too rigid, not flexible enough, and so on.
Thank you very much. And this is it. The questions of
Thank you for the
today
great
in
Q&A.
this.